Hello and welcome to Cos Thea's video on trigonometric graphs. We're going to explore a bit about sine, cos and tan graphs and how to work out angles and transform them. So sine, cos and tan, you have to know how to sketch them. Okay, this is something you have to know off by heart. Okay, so we're going to go through the sketches of them. So sine theta, what does that look like? It starts from 0 and it has this shape. Okay, it goes up and then down and then back up. It goes through at 180 degrees and it ends at 360. Okay, and then towards the negative x-axis, you just carry on the graph basically. Carry on going back down, back up. There you go. And that's going to be negative 180 and that's going to be negative 360. Okay, and the peaks are at 1 and minus 1. So that's sine theta for you, between 360 and minus 360. Let's go to cos theta now. So cos theta is a bit different. We're going to start from 1 instead. Okay, we're going to start here and we're going to go down and back up. Okay, notice how I didn't go through the middle. Okay, you go sort of quarter way through the line, if you like to call it like that. And this is going to be 90 degrees. Okay, because half of 180 is 90, and then that is going to be 270 degrees. Okay, because 180 plus 90 is 270, and you just carry on the cycle. So that's going to be negative 90, that's going to be negative 270, that's going to be negative 180, and that's going to be negative 1. So that's cos theta. This is also something you have to keep note of. That is minus 360, and that is positive 360. So it kind of cuts off halfway, because if you would carry on, it would look like that. Okay. Tan theta. What we're going to do is we're basically going to start from the middle and then draw something like this, so like this, and go back down and go like that. Okay, and this is going to be minus 90, that's going to be positive 90. So something to keep note of, tan always has a cycle of 180 degrees. That's the width of a tan, and it basically repeats every 180. Okay, so I'm going to draw another tan like that. That's going to be negative 90, and we're going to draw some asymptotes here. Okay, so what will this be? Well, it's a width of 90, right? So you just plus another 90, that's going to be 180, plus another 90, that's going to be 270. Go back 90 from here, you'll get minus 180. Go back another 90, you'll get minus 270. Okay, so that's what tan will look like. So in fact, let's change that from minus 270 to set 270. So these three graphs, you have to memorize off by heart what they look like. Now, we're going to explore them a little bit more, just a little bit further more in detail. The first question we'll have is, let's sketch the graph of y equals cos theta again. But this time, let's sketch the graph of y equals sine theta again. But this time between minus 180 and 270. So we change the interval slightly. And also, part B, solve sine minus 30. Show what sine minus 30 equals minus 0.5 is. Right? Show that on the graph, basically, what that represents. And use your graph to determine two further values for x, for which sine x equals minus 0.5. Okay, so don't worry, it seems a bit confusing now, but we'll get into that right away. What we're going to do is we're going to draw out sine theta. This time it only wants between these two values. That's fine. What I would recommend doing is just draw sine theta how you memorized it, okay, with a pencil or something. We know sine theta just looks like this, and we sort of know that that's 360, that's 180, that's minus 180, that's minus 360. And now we can just rub off the bits that we don't need. We don't need above 270. What is 270? That is 270. So, okay, we'll just get rid of, the bit above it, no problem. And we don't want below minus 180. Well, that's fine. We just rub that off. And there you have it. That is sine theta between minus 180 and 270. Now, part B. Sine minus theta minus 30 is minus 0.5. So, but basically what they're saying is that when you go to minus 30, you end up getting minus 0.5 on the y-axis. Okay, that's fine. Here's the interesting part. Find out other values of x for which sine x equals minus 0.5. So what that basically means is we're going to draw a line for minus 0.5. So here is y equals minus 0.5. That's what we've just drawn on. So where does the graph we just drew intersect that? Well, of course, that minus 30 that we were just talking about, but also here, whatever that is, and also here, whatever that is. Okay? So what are those two values? Well, here, you kind of need to take into the consideration the symmetrical shape of a sine graph. Okay, let's make it a bit less messy. This, remember, this is minus 180. If I went back 30, I'm going to go forward 30 from here. Okay, so I was at minus 180. I'll go forward 30, minus 180 plus 30. That should give me minus 150. Therefore, that is minus 150. Okay, how did we get that? From the symmetrical shape of the graph. And from here, we're going to do something very similar. This is 180 degrees. We know that we just have to go back or forward 30 degrees. 180 plus 30 degrees, that should give you 210 degrees. Okay. So what are the other two values of x? Well, x must be equal to 210 degrees, and x must also be equal to minus 150 degrees. Okay, those are the two values for x. Now, you also have to sketch other versions of sine, cos and tan graphs. This is something you have to sort of memorize from GCSE. So they might say sketch y equals 3 sine x, for example, right? Well, we know that, just quickly, sine x looks like this, between 1 and minus 1. Well, what does 3 sine x do? 3 sine x is the same thing as saying we had f of x, but now we've got 3f of x. What does that do? That stretches the graph in the y-axis by a scale factor of 3. So our new sine graph basically looks the same, but it's a bit more stretched in the y direction. And, it goes at minus 3 and 3 instead. And that's really it. You might also have sketch tan theta plus 45 degrees, right, between 0 and 360 degrees. So here's a bit more variables involved. Now that's fine. Again, what would tan look like normally? Tan looks like this normally, right? What are we doing? We're just shifting it 45 degrees to the left. Plus 45 means to the left. So instead of asymptotes being at 90 and minus 90, they're going to be shifted to the left by 45, which is no problem. Okay. So look like this instead. Where that is 45 degrees. So we've got asymptote at 45 degrees. But the width of the tan graph stays the same. It's always going to be 180 unless you stretch it in the x direction. This is also going to be 180 degrees. Okay. So 45 plus 180, 225 degrees. And you've got another cycle there. (225) plus 90, you get 315 degrees. And you can cut it off wherever you like. 360 is what they wanted, so you just call that 360. And then that's it. You can ignore the left hand side of the graph, and that's all you have left. Thank you for watching the video.